7 and 1, 9. We're going to start with 1, 6. Okay.
Notes or what is that?
Yep, this is notes. I'm going to go over what is in 1, 6. It may be a little different than what you did. If you've written some of this stuff down, you don't need to rewrite it, but you should pay attention to what I'm saying. I sometimes give different things to the answers. Okay, so this section is called order of operations. Okay, so when we're looking at this, it's talking about what order of operations. What order do we do operations in math? Operations are those things like adding, subtracting, multiplying, dividing, taking the square root, taking the absolute value, squaring something. So I would x to the second, that little power up there. Okay. Also, it could be, parentheses. Like that. It can be parentheses like this, which are brackets more like. Okay. It's doing those operations. That's the order that what we're looking for. Why do we have to have rules of operations or an order of operations? Yes?
Because it won't add up correctly.
Because we'll get the same answer. If we don't have a rule to follow, it's kind of like not having rules on the road. It wouldn't work well. You're not going to get the same thing. You need people to follow rules in order to go with this. This is just man-made. Man decided this is what order we're going to do the operations in. They could have decided to do them in a different way, okay? But they came up with this way of doing order of operations. So really, this is just so that everybody that does a problem gets the same answer, because if I give you just a problem and you don't do it in this order, you will get all sorts of different answers, depending on what you do first. Okay, I'll tell you the most common mistake is this. Okay, do you know what the mistake is when they're doing that? What do you think they do first? Yes.
They do plus first.
Yeah, they do the adding first because it's right there. It's the first thing. Because we read from left to right, we look at our math and say, well, we should just go left to right. It doesn't always work that way. Okay? So if somebody just read this going left to right, this would be 7 times 7, which is 49. But that's actually not correct because our order of operation says do 4 times 7 first, which is 28. 3 plus 28 is 31. That's our actual correct answer because we followed the rules of or order of operations. Okay? So let's just talk about that order of operations. Okay? When we start working, the order of operations is very important. Okay? Now I'm going to give you the old famous acronym. Does anybody know what the famous acronym is? Yes?
PEMDAS.
Yes, it's PEMDAS. Okay? I'm going to write it a little bit different. Okay, the reason it's called PEMDAS is if you go PEMDAS, that spells PEMDAS. That helps you to remember what order to do your operations in. Okay? The problem with PEMDAS is it doesn't include everything. Okay? So parentheses really encompasses a lot more than just parentheses. Okay? It's any grouping symbol. This is a grouping symbol. Which one is a set of parentheses? That does group them. Okay? All of section 1.7 is about what other things are grouping symbols. That's what we're going to talk about in 1.7, the other things that are grouping symbols. So we say parentheses, I think it should be GEMDAS, a G for grouping symbols, okay, instead of a P. But they didn't ask me when they came up with this acronym, so it doesn't matter what I think, okay? But grouping symbols are not just parentheses. They could be many other things, and we'll talk about what those are in our next section, okay? What does E stand for? Yes?
Exponents.
Exponents. Now what's very weird is exponents. Exponents. Okay. With exponents, there's actually another thing that goes with it. We include multiplication and division because they're related in the same line. We include addition and subtraction because they're related, okay? We don't include the one that's related to this. It's a radical. So it's exponents and radicals. You might not know what a radical is yet. We're going to talk about that in grouping again, okay? But it actually has two parts, exponents and radicals. The reason why is we actually learn later in algebra that a radical can be written as an exponent. It's just a fractional exponent instead of whole number exponents. We've been working with exponents. Where have we been working with exponents? What kind of exponents have we used? Anybody? Yes?
Like we've been using like the power of like 7 or like the power.
What's our base number that we're mainly using?
Oh,
10. We're putting exponents on 10. Okay? That gives us different numbers by doing that. Okay? Positive exponents mean we're going to do what with the tens? Yeah.
Like move it over to which side?
Yeah, sure. We're going to make the number bigger, right? Because we're multiplying by 10 many times. What does a negative exponent give us? What does it tell us to do? Yeah.
Makes the number smaller.
It makes the number smaller. What are we actually doing there? We're not multiplying by 10. What are we actually multiplying or doing?
Dividing.
We're dividing by 10. So a negative exponent just says you're dividing by this number that many times. Okay, so that's the difference. Positive, in this case, doesn't mean directional. It means whether I'm multiplying or dividing. Positive is multiplying, negative is dividing. Okay? Then it's multiplication and division from left to right. Now, the other thing you could do is in math, in algebra now, or in pre-algebra now, we kind of drop the division sign. We don't put it, kind of like we don't use the multiplication sign anymore. So our multiplication signs, we change these a little bit. So here, multiplication either becomes a dot, or if I put a number next to another number, that means multiplication. Okay. We don't use the times sign except for in scientific notation. In scientific notation, you do use the times sign. That's an argument between mathematicians and scientists. Scientists have won so far. Okay? They still use the X for the multiplication in scientific notation. That's the only time we use it though anymore. Once we get up, I wish we just went away from multiplication sign and used a dot all the time so it wouldn't confuse people when we get here later and we are starting to put X's in and we have to drop the multiplication sign because it looks too much like an X and we make it a dot or an at. They actually used to use asterisks in, if you're doing it on the computer, they used to use like the little asterisk button like that to indicate multiplication. So we changed it because when we started typing on the computer, you couldn't distinguish, and you can't even distinguish it when you're writing on paper, if that's an X that's a variable or if that means multiply. Okay, so that's why we had to change that. Okay. Division, instead of writing the division sign, no more, we use just the fraction bar. The fraction bar is the same as division. So when you see So this is no longer used, kind of like the X is no longer used. Well, that didn't make sense. Okay. The X, I'll put a circle with that, is no longer used. The division, I'll make it more clear, is no longer used. We use the fraction bar. Okay. So as we go along in algebra, pre-algebra, just get used to the fact that I'm not probably going to use this sign, and I'm probably not going to use that sign. So for multiplication, most of the time you're going to see me use a dot. I try to remember that in pre-algebra to use it. If I don't and I put it like this, just know that's also the way it's written, because I'm so used to writing things like that, I don't always remember the dot. I try to put it in for you guys as pre-algebra students, just to get you used to being the fact that it's multiplication. Okay. I use the fraction bar for division, just because it's much easier. It doesn't get confused with the what order I have to do these. So when you actually do them in a different, like this, the thing is that anything that's up above this, you do first, and then you divide, okay? And so it says multiplication left to right and division left to right, but really they're the same type of thing. Multiplying and division are really inverse operations. Because if I multiply 2 times 3 and get 6, that's one of my math fact things. But I can say 6 divided by 2 is 3. We're using the same numbers, we're putting them back and forth. One takes the other and reverses it, basically. Okay. This is not the right one. Sorry, that's AS. This is addition and subtraction from left to right. Now, I'm not going to confuse you and start using the way that I teach that more in algebra yet, because it would be totally confusing to you. But, so we will just stick with, you do the addition or across the way, but you do addition and subtraction at the same time, going from left to right. Okay, and that makes it easier. Okay, okay, so let's look at some problems. If I have let's not do that. Okay, let's just look at this problem. Looking at our order of operations, we're looking for parentheses. So what are we going to do first? Yes?
We're going to do 3 times 5.
Yes, we are going to do 3 times 5. We must do this set of parentheses first. So when you're learning this, a good way to do this is underline the thing you're doing first. Okay? Then I'm going to go ahead and just write everything down except for that answer. So I have 2 plus 7 times whatever this answer is. Okay, I'm going to put in there the answer. That's 15 minus 6 divided by 3. Okay. Fran, what am I going to do next in this problem?
The fraction.
Okay, we can do division. Could we have done something else at this time? Marcy, what?
Multiplication.
Yeah, we could do both multiplication and division. So this is where I cheat. I do 2 steps at once. Because I can say, oh, let's do this and let's do this. They're 2 separate things that are going to be subtracted. They don't interact with other multiplication or division. So we can do them separately, and we can do them at the one time. Okay? So this is going to be 2 plus, who wants to tell me what 75 is without getting their calculator out? 7 times 15 is. Who wants to tell me that without getting their calculator out? I'll give you a hint. If I take 7 times 10 plus 7 times 5, because 75 or 15 is really 10 and 5. Do you agree with that? Okay, so I could take 7 times the 10 because that's in the 10 spot. 7 times 5 because that's in the 1 spot. What does that give me?
105.
That gives me 105. I can do this in my head a lot faster. 7 times 10 is 70. Whew, that's not hard to remember. Then I go over and do 7 times 5, which is 35. 35 and 70 are 105. So you can do your math in your head by doing tricks like this. Separate it into 2 parts. Do the addition. Do ones that have zeros on them. That's what you want to get done because those are easy and you can remember them. Okay? Yes?
Can I go blow my nose? Right?
Yes. Yes. Okay? So we got 105 here. Minus, what is 6 divided by 3? Yes. 2. Okay, not a hard problem. So we wrote down the answers to those problems. Now I am going to go from left to right, doing the adding and subtracting. So here I've got 2 plus 105. So that answer is 107. Then I have minus 2, and I'm back to 105 again. So I followed through. You can look at, I can look at this. This is why I'm asking you to write it down similar to this when you're doing homework. Because I can look and see, oh, you did the grouping thing first and got that answer. You did the multiplication and the division and got these answers. You did the addition and then you did the subtraction. So when you're showing your work on this, show me step by step. Do not go from here to here. I will not give you, I'll give you 1 point out of 4 for that. Okay? Because I want to see the work to make sure you're getting the idea of how to do it. Now later I'm not going to ask for every step. But right now I'm asking for every step so I can catch things. Yes?
If we do like extra steps, like, and do it more, do we get more points? Or like,
If you want to do 1 step at a time instead of joining 2, no, you don't get extra credit, but it's showing me. Okay. So part of this is understanding what you can do at the same time. If you need to, do 1 step at a time. Okay. But if you understand which ones can be done, because this is a separate multiplication than this division, you can do those at the same time. Because they're separate from each other. They're not connected. Okay, so that's basically what 1-6 is about. It's just showing you how to work with these different numbers, doing the orders of operation. One reason this is important, I said before, is you will get the same answer as every other mathematician. That's important, okay? But it's also important because when we start solving, we're going to use the opposite order of operations. So you need to know the order of operations to go in the opposite order of operations. Okay? That's not going to happen for a while. Okay, so we're going to look at 1.7. 1.7 is just going into the groupings that are referenced by parentheses. So when we say parentheses, it means these symbols. They look like parentheses. Okay. It also includes any brackets that may be used. I can't draw them, but that's a type of bracket. There's also this type of bracket. Those are all used when we do parentheses. Now, sometimes we don't do it like that. Sometimes we just have inner parentheses. So I might say 3, 4 plus 5, 7 plus 2. Okay, I have a parenthesis inside the parenthesis. You always do the innermost parenthesis first. So you always start with the inside parenthesis first. Since we started using computers, you more often see it just with this, or especially with calculators. If you're putting it in your calculator, it's not going to let you put brackets or those bar things around it. It's just going to have you put parentheses inside parentheses. So we see more of this now, like this, where there's two sets of parentheses, okay, than we do with the brackets or those, I don't know what they're called, closed-in symbols, okay? Just because it's easier to put one parenthesis on a calculator than having all those different symbols on the calculator. So you just have to realize you have to always close your parentheses. What closing your parenthesis means, I have to have both, that is closed, because I have one facing the that way and one facing this way, so it's closed. This is closed, okay? I don't go around, like this one and this one are not closed, because I have one inside of it, okay? So just being able to read those parentheses, especially when you start using calculators. You won't get the correct answer unless you put it into the calculator correctly. And a lot of times they're going to ask you to put parentheses in there. Okay, yes?
These are called nested parentheses.
Thank you. They're called nested parentheses. I don't use that I say inside the other. But yeah, nested, if you want to get technical, they're called nested parentheses. That's what it said inside, or in our textbook. Okay? So, oh yeah, I did see nested parentheses. Okay. The other one that works as that we use a lot is our fraction bar. So if we have something like 7 plus 9 and 2 plus 1, that fraction bar acts as if there's parentheses on the top and there's parentheses on the bottom. So really what this is saying is this. You have to do what's ever on top before I do the division, and I have to do what's ever on the bottom. We don't normally write those parentheses there. So you just have to realize when you have a fraction bar, and if there's adding and subtracting or multiplying, you should do all that on top, whatever's on top, do what's on bottom, and then do your division after that. So the fraction bar is like a parenthesis. Okay, so in this case, this would be 16 divided by 3. Because we did what's on top, then we did what's on bottom. That's 5 1/3 if you want to change it to a mixed number. I have talked about in here, we just use them as improper fractions because it's much easier to know what we mean. Okay? So that's the key. A fraction bar acts like parentheses. We don't usually see it, but I always tell people if you need to, put the parentheses on the top of the fraction, put the parentheses on the bottom. In fact, if you're doing something in the calculator, you're going to have to do that or it won't calculate it right. You have to put it, whatever's on the bottom or whatever's on the top, in parentheses so it will calculate it correctly. Okay. Okay, another thing that gives you calculations or grouping signs is if we use another operation. Okay, absolute value. So that is a symbol. If you have two things in there, let's say I have 2 minus 7. Have we talked about negative numbers yet and integers? A little bit, yeah. So if we do this, that bar, it kind of looks like a parenthesis, but it means absolute value because it's just 2 straight lines, okay? So inside there, I have to do that first before I do the absolute value, Okay, so in this case, this would equal 2 minus 7 is negative 5. If you don't understand that right now, that's okay, but that's what it is. Absolute value is the distance from 0. Negative 5 is how many steps away from 0? Yeah. 5. So since it's the distance from 0. The distance from 0, when we measure distances, we measure them as positive numbers. Okay? You don't hear me say that I measured the depth of your book and I got negative 2 inches. Distances are measured in positive numbers. We don't go negative 60 miles. We go 60 miles. Okay? We don't say negative 60. So distances are always positive. Okay? Measurements are always positive. Now, sometimes when we put it on a scale, we might refer to some distances being negative because you're going below where we started. That's a whole different thing. But actual distances are positive. Okay. The other one that is another one like that is the square root. Okay, so if it's inside the square root, this is called a radical. The thing I wrote up here, oh, it's not there yet, but the radical. Okay, this one is read as the square root. Okay, I'm just going to add, so we do stuff inside first. 16 plus 9 is 25. Does anybody know what it means to take the square root of 25? It is the opposite of squaring something. So it asks, what did I square? What number did I square to get 25? Yes. 5. So the square root just asks the question, what number did I square to get 25? And that would be 5, so the answer is just 5. It's not squared, it's just 5. Because it's only asking for the number that was squared. Okay? That's, if you don't know how to do that yet, we again will work on those more. We're going to come up and work on those more. Okay? Just some preliminary things that you're looking at there. Okay? So this tells you that there's a lot more to parentheses than just the set of parentheses or nested parentheses or brackets. You can use the fraction bar. Any other operation that they're marked inside of is also, you do those first. Okay. Okay. That's the end of that one. Let's do a couple problems now as examples. So I'm going to have you do these on your paper.
Wait, are we doing it on a paper or like okay?
Nah, we'll do it. Oh, we can do it up there.
Yes.
Okay. So how about if you guys go up to that, you guys go up to there, you go up there. Okay, on page 37. Okay, 9, right, 1, 2, 3, 1, 2, 3, 1, 2. Okay, you're doing Gavin, Jonathan, and Bran. You're doing on page 37, 9 through 11. Yes. Okay.
9 through 11.
Yeah. Remember that is.
When
Okay.
Brandon and Ezekiel go together? Instead of 3 and 3.
That's fine. I can just do it. So, okay. So Ezekiel, Marcy, and Lil, you're doing 12 through 14 on page 37. So it's page 37. Remember the numbers I give you. And you two are doing on page 37, 15, and 16. Okay? Okay. So I should see each of you helping, since if there's 3 problems in your group, 1 person do each problem, write it up.
Wait, 116? Oh, wait, first. 9 through 11.
9 through 11. One of you do number 9.
Me.
You can talk together about it, but have that person write it.
All the 11.
Another one do number 10, and another one do number 11. Same thing here. You are doing 12 through 14.
Okay.
So from now on, when I give these to you, write them up on the board, page number 12 through 14, so you have it. Do you guys have a marker? Okay. Does everybody have a marker? Okay.
Right. That one. Your mother is 1.
Can I just do the problems for myself?
No,
I
you
work
can
better
work
alone.
them. I want you to try to
I don't like
participate.
working group. I don't like problems.
Okay. So can you do number, they're doing 12 through 14. Can you do number 14 on your paper and then just write it up on the board? Okay. Thank you. Just do it on your paper, just 14 though.
I don't know.
We have a marker.
I have one. Kitty.
No.
Okay, you can go. Alright, 55 minus 4 times 7. So 4 times 7
Oh, say the one.
is 55.
But you can't say the one.
That's why. Alright, so it's 4 times 7 first, which is 28. Okay, 28 minus, or no, 50.
28 minus 55.
No, 55 minus.
Can I borrow one of these markers?
Yes.
Thank you.
I was thinking of the 5 times 7.
Or just,
I have a question. So look at that. If I multiply by 10, what does that do to my decimal? How many places?
Alright, who's next?
Write it big enough so we can see it.
yeah, right.
Or next.
No, I got
Or
it.
next.
Well, we don't need to write it that big, okay?
Next, okay. 9 plus 7 is, so 16 minus 16. It's
Yeah. And then it's 6 plus, so just that's 16. I don't know.
It's 9 equals 27. Number 9.
Okay.
I think he's doing the last question.
He's doing 14. So you guys do 13.
Minus 3. Minus times 17 is
Wait, that has been there since
You're
2023.
doing 200.
It has.
That's a landmark.
200 divided by 5. It's 200 divided by 5. Can I go down and grab water real quick?
Yes, I'm so thirsty.
And Gavin, when you get back, I need your homework.
Yeah.
Okay.
Wasn't it 1 dash?
1, 5, and 1, 8.
Okay.
Yeah. So, okay, I'm a little rusty at my division. So,
Where will you like?
so I got to here, did the parentheses first, and I got 1/16.
Okay.
And then I'm dividing 116 by 4.
You gotta do your exponent first.
Oh, right.
Then we're gonna divide by 4, and then we're gonna multiply by the answer.
Squared.
Alright,
And then you do 14.
3 times 3.
I'll just write it down. They get my answer.
Let's see, you did first, let's see, what part did you do first?
Well, I just
Oh,
erased
it's
it.
20 divided by 2, okay,
Times-
which is 100, times 10, which is 1,000 minus 4. I'm gonna tell you the way you've written it is incorrect, but the answer is.
I remember this
36.
division, that's why.
Well, no, I'm gonna show you why and how I would like that written, we're gonna talk about that, okay? So, yes, now it's 9, so what do you have?
Then do I do 116 divided by it, or do I multiply?
You know, you divide first, left to right, so.
Oh,
So 1
the answer is 0.2. I got you.
That's fine, but, okay, what'd you get, let me see. 0.3 times 4, 0.34 is 1.2, minus 5, is it 5 times 0.02?
Yeah.
Okay, so 5
No, it's not.
is 1. I think I would switch this around because that's not a correct statement. Do you know why? 1 minus 1.2 is not 0.2. But you have the right answer.
negative.
Yeah, so what would the right answer be? Because I want to write it first answer minus the second answer. No, it's not negative. What was this answer?
So,
That.
1, no, 16.
And that one, then I subtract this answer, which is,
Then, that is not right there. How many times
yes, yes. Okay, so once you've done your 3 problems or 2 problems, look up here. I put the initials of your group up here. So on page 42, you guys are doing 14, you guys are doing 13, and you guys are doing 11 and 12. Okay, yes. So you don't want to divide by 9. This is 116 divided by 4 times.
We have 14.
You see that? 'Cause this is 116. The division sign, let's make it into a fraction bar. It's much easier to read.
No, bro, that's us.
Times 9.
We have number 14. Jonathan,
So
Ransom,
what is
Gavin,
116
But then
divided by
why-
4? How do I do that?
Marcy,
that's
Lillian,
tricky.
and Ezekiel.
Okay,
No, she's with us 9
so
to
the
11.
first thing I would do
Yes,
is
and
like
now
this.
she said if
Okay.
you're done with those,
Oh,
you're number 14.
so we're
But
taking
you gotta
4
sign,
into it,
you guys
right?
gotta sign 14.
So if I thought of
Oh, guys,
4
page
times, we're gonna
42,
start
page
with
42.
10s. 4 times what? Will
oh,
give
there
me
we go.
something
Alright,
close
guys,
to
number
100.
14, page 42.
I need to turn
Alright, 35 plus 10 over 35 minus 10.
Right,
Oh,
what about
that's
4
easy.
times 20?
We got 5 or 10.
That's what about it.
What number is it?
What about 4 times,
10.
Alright, that's it.
what about 4 times 30? Was on 90.
Oh,
We're gonna lose 120, so it's not gonna be that much. Okay,
sorry.
so let's take 20 times 4. That gives me 80, right? So we've used 20, so that gives me 36 left. 8 minus, 11 minus 8 is 36.
So it's like,
How many times is 4? What number times 4? 8.
Right now.
so
Okay, now we're down to 0. So what we did is we took 20 and 9 and got the answer the same as this. So the answer
Well,
is
that just
29
goes out.
division.
well, I mean,
So now I have 29 times 9.
huh?
Now, a fast way of doing this? What is 29 times 10?
Saucy
Yeah,
Saucy
but I don't have 10. I only have have 9, but if I take 29 from this, it will be a
5 or 10.
Does that make sense?
Yeah, 5 or 10. That would be 16.
And then you're gonna look at 11 and 12.
Actually, no, that's a
So
one.
much you cover.
It's a one.
8.
Getting 15 done? You know what, guys? Yours is a mess.
You're right.
I would like you to write it very neatly so I can follow it. So can you rewrite that so I can follow it?
Can I keep mine? Is this okay?
You decide if it's nice and neat. I would say extra things that are written on there should be erased. That would be my first thing.
Yes.
What happened to number 14?
Oh, I just we're gonna work on 42.
No, but we need to see both of them.
Forget this.
That was hard. We need the answers though.
Bro, we do
No, he erased my answer.
Okay, don't erase nothing else. Nothing else. 14 else.
Okay, drawing pictures right now is not the thing we want to be doing. I mean,
Erase everything.
if you put a little eye that's not interrupting things, that's fine. But when we're drawing whole bunches of things that I can't read, that's the problem.
Okay, guys, this is good. This makes sense. That
Mine
makes
makes that doesn't make sense.
No!
I'm number 10.
Actually, I was 14. No, we're 10.
I'm number 10.
There you go. I need to mark on
Number 10. Okay, what was mine? What page? Why are we on 43?
Because we're supposed to be on page 42 doing problem 14.
Hold on.
That is correct. There you go. Okay, go to the next one.
I'm the dude.
11. Do it somewhere up there. Make a little square around it and do number 11.
Minus parentheses.
Oh, look at that. 121. The problem is, what is the square root of 121? What number did I multiply by itself to get 121?
Okay, I'm not
Let's think of 10 times 10. What would that be?
100.
That's a little bit less. What's the next number?
Oh, 11.
Oh, how about that?
Okay, so
So it'd be 196. Don't erase it. 196 minus. There you go. Perfect.
Ready? Ready?
100.
Good job. Okay? The squares, we'll learn how to use the square root button, but you should know up through 12. Okay? 12 is 144.
Pretty sure my old school tried to teach me to use square roots when I was like first grade. I'm not even joking. They were like
No.
using those symbols and stuff. And I'm just like, what's
No,
going on here?
no, they shouldn't be doing that. That's way too difficult.
Because like how I don't like this.
Okay, Bran, I really am saying please do not do that. Bran, please do not do that. Thank
What
you.
was the answer to what did you
Guess how good I am at
Did you
drawing.
get kicked out of class? No.
Yeah, that's
Guess
correct.
how good I
Listen to
am.
your teacher.
Okay, so now we've done our last one, okay? Where's your next problem? Somebody could be writing number 14 up there.
Number 14 is 35 plus 10, the other one's 35 minus 10.
Okay, well, let me see, 14 up there. Go ahead, no, write 14 up on the board.
No, not up there. That's my.
Just,
Is it
what one do you want to do? Number 14.
Yeah, it looks like you've done a good job. Let me double check it. Is that 17 squared? It's not 34. Put it into your calculator and see what it is. 17 times 17 is what you need.
Come on, no, we have to write it. We have to write 14.
Oh, you just did 17 plus 17.
Yes, you did. You did it multiplied by 2.
That is not.
Do you have a calculator? Ezekiel, can you do 17 times 17? He has a calculator. Ask him to do it.
Alright, we had
Okay, definitely not gonna have you guys work together. Definitely not.
So
I'm trying to work. I'm trying to work. 35 plus 10.
We did it. We did it.
Okay.
It's just obviously gonna be 6 over 3, guys. It's 6 over 3. I'm sorry. I know.
11.
You don't have to do it like this.
I did 11.
add another step.
Okay.
No. Bro, we have to do it.
Okay. What's number 14?
Just focus. Just all we need is
So where is it? Where is it?
It's right here.
Okay. Oh, 14. 14. Okay.
I want to try this right.
I'm not doing that.
No. No. All right. All right. We have to give the. We can't now.
How you doing?
Okay.
35.
All done?
11. Number 11. Would that end up equaling 40?
No, we don't. It's a thing. 45.
For
5, 200, 200 divided by, oh, page. What did you say? 40?
Oh, wait, hang on. Just a
Plus
second.
2 is 14, 3 times 14 is 52.
Where did you get 11? Where did you get the number 11?
But it needs to be on page 42.
Oh,
Yeah, which is on page 42. Check your page number.
On number 14, at the very last answer, should we reduce 45 over?
What do you think?
Are we not using calculator?
1, 2, 3. 23.
Okay. Now you can double check it on the calculator if you want to.
Double check.
Okay, guys, what do you think? Would you reduce it?
Yes.
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 So reduce it.
No. Which one do you want to do? Wait, that's 1/3. It's 11.
I'm just writing it down.
It's crazy.
Bro, I want to go home, bro.
No.
Reduce already. Come on, let's reduce. $45 over $25.
It's 5 over 9. It's 5
Right,
over 9.
right.
It's 5 nights. It's 5 nights.
5 nights notice. Really?
Okay, we're gonna give you about 2 more minutes. Actually, finish up. Go ahead and take a 5-minute break right now. Okay? So, but do not erase what's on the board.
That was too much.
We are gonna talk about how we should write these. Okay, let me go see what's over here. That's Elijah's from geometry. And we've got Gavin's, Jonathan's. And then I have Meds and Max's. Let's have everything in there. Oh my gosh, have we been taping this whole time?